Hey guys, welcome to another video. Today's learning objective is multiplying a single term over a bracket and taking out common factors in regard to algebraic manipulation. If you haven't already, make sure you check out the previous videos on kind of algebra. They're going to be really important to make sure that this all makes sense. But if you kind of know what's going on, for example, and you want to skip to a certain point in the video, say a worked example, the timestamps are here. Just as a quick review of, say, last time's lesson, just to make sure, perhaps you remember everything. Just quick question, for example, what does 5x equal? And, can you do this? And can you tell me why that equals, say, 5x? So if you can do this, you can probably remember the last lesson well enough to give this one a go. Okay, so first thing let me do is kind of ask a question, I guess. What is 2 times x plus y? Okay, well, this is 2 times x plus y, but we know, for example, 2 times x plus y is the same thing as saying x plus y plus x plus y, right? We put this in brackets again, and that's kind of cross multiplication, long addition, which becomes 2x plus 2y. But the thing is, so we can, if you see how that's played out, you can see, for example, that this is something we could have just done 2 times x like this, and then 2 times y like that, and then added. And this property is known as distributive. It means that because of the bracket here, the 2 in front here applies to both the x and the y and can be kind of distributed across the bracket. So say if we were to look at another example, what is 3 into a plus b? Okay, well, so our distributive property tells us what we can do is multiply 3 times a, and then this addition sign will kind of stay there, and then we can do 3 times b, which is 3a plus 3b from our distributive property. So that's kind of all there is about kind of multiplying a single term over a bracket. So we've got the single term, say the 3, and we multiply it over the bracket. So we look at kind of a bit more of a more abstract one, I guess, or more algebraic one. We can have, for example, what is 3x times by x plus y? So we can't really use this, if we were to use kind of this logic here, it'd be a bit harder here because we don't know what x equals. So we can't add x plus y 3x times. But we can use this distributive property here, definitely. So we have 3x. So we can multiply 3x by x, and then we can multiply 3x by y, and then add them together. So 3x times by x, so let me get another colored pen, 3x times by x, and then we can do 3x times by y, which equals to 3x times x is 3x squared plus 3xy. And if we remember from last video, just as a quick reminder, 3xy is the same thing as 3yx. If just as a reminder that they can be flipped around, and sometimes a bit, questions a bit cheeky sometimes. So knowing this distributive property, let's try out our first question. Okay, expand this thing here, 6x into 6u minus 4v. Okay, let's write that out again. Minus 6, oh, wrong color. Oh, okay. Well, okay, 6x into 6u minus 4v. Okay, so again, distributive property. So we can multiply all of this thing here, which includes the minus sign, minus 6x times by 6u, which is minus 36 s times u. Oh, so actually, let me write that down a bit more clearly. Minus 6x times by 6u minus, so we copy this one here, right? Because before we had the addition, we copy that, and since it's a distributive property, we can just kind of copy this sign here. Let me do kind of minus 6s times by 4b. Okay, so and that's, we can kind of do here is minus 6 times 6, minus 36, and then s times u, we can just write that as su if we remember, and then minus 6 times 4, minus 24, and then sb. And if we remember, kind of 2 minuses make a positive, minus 36 su plus 24 SV. And a lot of the time, people like putting the positive one first, so 24 SV minus 36 SU, to get this right here. And that's kind of our answer there. And now, we've expanded things out, right? But sometimes there's a way, sometimes you want to go from, instead of going from here to down, all the way down here, sometimes we want to go from here to here. Because, of course, this is a bit more concise, a bit more clear sometimes. And it's just sometimes a bit useful to do that. And so when we go from this way around, that's called expanding out. When we go from this way back to here, that's called factorizing. And you're thinking, why is it called factorizing? Well, what we're doing is we're looking for common factors between this one, this, and this, and then kind of taking those outside and putting everything else in a bracket. So let's kind of think of a bit more of an easier example first. So let's say we have we're asked to factorize something like 36x squared plus 5xy. Okay, so 36x squared can be written as 36x times by x plus 5y times by x. And we can see here that the x is the common factor. These 36x squared can be divided by x, and so can 5xy. So we can take the x out, and we get 36x plus 5y. And if we multiply this out, we'll go from here back to here. So the way you factorize, you look at the terms you have, and you think, what's common in this, and that's common in this. So with the variables, it's fairly easy. You'll see, oh, there's two x's here, and there's one x here. So they both have one x in common, so we can take the x out. But with the numbers, sometimes it's a bit harder. Sometimes we might have to go back to our prime factorization, if you remember that video. But in this, we're kind of lucky. We know 5, for example, is the only it's a prime number. The only factors are 1 and 5. And 36, we know is kind of 6 squared. 5 doesn't really go in there because it doesn't end in 5 or 0. We know our divisibility rules. But for example, if we have a bit of a perhaps harder one, I guess. If we had, for example, instead of this, we had 36x squared plus 72xy. Well, in this case, we can notice the 72. There's a factor of 36 in both of these. So that can be written as 36x times by x plus 36x times by 2y. So again, we've got common factor here. We can take the 36. Sorry, see, I keep forgetting the equal sign, and this is kind of a bad habit actually. Make sure you put the equal sign straight away. So 36x, we can take that out and leave in the brackets x plus 2y, like that. So this is just that's factorization. So let's move on to a worked example. Factorize this thing right here. So why don't you pause the video, kind of give the question a go. Just remember what factorization means. You look for common factors. The factors are in both. Okay, did you give the video and pause? All right, cool. Back. Nice. Okay. 40 EK minus 64 EU. Okay, well, with these variables, the most obvious thing is that we've got a common E, right? That's the first thing I noticed. So I know I can definitely take the E out. So why don't we just kind of skip straight to that step? We take the E out, and then we're left with here 40K, and here minus 64U. And how do I know I'm left with this? Well, if we're dividing by E here, that E just goes away basically, and we're just left with 64 times U. And the same thing here, we're just left with that. So let me get rid of those crosses. Okay, now we can think again what kind of common factors there are. So the variables, there's no common factors, nothing common between K and U. So let's look at the coefficients, these numbers in the front here, 64 and 40. Okay, well, I can tell they're both even. And on top of that, I think I can actually tell that they're divisible by 4. So 40, of course, is divisible by 4. That's 4 times 10. So why don't we write that? So back to our black pen. E is 4 times by 10K. And 64, well, I know 40 is divisible by 4, right? And then 40 plus 24 is 64, and 24 is divisible by 4. So we have 16 times by 4U. And then we have E, and then we take 4 out, and then 10K minus 4u. But look here, these are still both divisible by 2. So we have to do this a bit more. So we can take another factor of 2 out. So we go 4e times by 2, and then we get left 10 divided by 2 is 5, and then 4 divided by 2 is 2 minus 2u. And then so we're left with 8e and then 5k minus 2u. And so a lot of the time, the process of factorization might take multiple steps, and don't be worried to take multiple steps, because it's not easy always to factorize, especially with numbers like 40 and 64. So if you need to, for example, then you're struggling with finding factors, we can go back to our prime factorization trees. So we can go 40, and then we go 4, 10, and then we have 5, 2, and then 2, 2. And what we're really doing is just finding the LCM between the two. So if you remember that video, finding the finding the highest common factor between the two. So that becomes 2 cubed times 5. And then we can do 64 as well, which is 16 and then 4 that we did, which is 4 and 4. Oh, look at me, I actually made a mistake here. So we'll take the 16 out, not the 4, right? So we have 16 here, and then 8. That was my mistake there. So yeah, we have 2, 2, then 2, 2, which implies 64 is equal to 1, 2, 3, 4, 5, 6, 2 to the power of 6. So we can see that the highest common factor here is 2 cubed. There's 3 2s here, and there's 3 2s here as well. So that's why we have the 8 out here. So then the number out here, the coefficient out here, is just going to be the HCF between these two coefficients. So if you're ever struggling to do that, just go back to HCFs, or you can work through it like this way, thinking, I see a 4, and then taking the 4 out and then saying, oh, I see another 2, and then working through like that. It just depends what you're more comfortable with. But if the really big numbers and you're struggling to see common factors, worthwhile using this prime factorization method. I hope that all made sense. It was again if this is all new stuff to you, it's really important you do practice on this. I'm sure you're sick of tired of me saying this, but just practice makes perfect. The more you practice, the more this becomes second nature, and the more you can just see a question, you know exactly what to do. Which is really important, because in the exam, for example, you're not thinking, oh, what do I do? You look at the question, you know exactly what to do, and you can attack it straight away. But yeah, see you guys in the next video.